So in the first part, we talked about how to design document structure in MongoDB. Also, basically, it's very flexible. So it provides a flexible data modeling. So you can utilize many different design choice when you design document structure for the MongoDB. And let's just say that you have some collections which you created to store data inside the MongoDB server, and you have multiple documents stored there. And the next thing you want to do is utilizing those information and retrieving and finding necessary information from the MongoDB server. So we have to know how to utilize the query in the MongoDB. So to practice those things and to cover those parts, I prepared a sample data set on the Blackboard. So some of you already downloaded this, and but if you didn't download it, you can go to the, let me show you. You can go to the Blackboard here. So if you go to the Blackboard on the course content, if you scroll down, then there is this file here. There's this file, zips nyil.js and zips txca.js. So both are JavaScript file actually, because MongoDB supports JavaScript environment. We can prepare file like this and we can open it in the MongoDB shell and we can perform the script written here. So to download this, like there are this file, zips nyil.js, zips txca.js. To download this, you can right click on the file and there's a save as option. It could be in my PC, it says save link to the content as. It could be save as another name or whatever. Find this save link to the content as, and you can click this and you can save it inside your computer like this. In my case, I already have zips nyil.js, zips txca.js. I already downloaded it on my PC. So you can download this. If the download doesn't work, another option is that you can click this file, then it will open like this, and you can copy this too. So it's not a super big file, so you can just click here. You can press the Ctrl A, then it will select the entire part like this. And then you can right click on it and you can copy it and you can put it on the MongoDB too. That's another way. So either way is fine. So in my case, I download it and I'm gonna open that in my MongoDB. So after doing that, you can go to the Robo3T. You can go back to the Robo3T here. And if you want to open new JavaScript file, or then you can use this option here. Wait for a second. So first of all, to open JavaScript file in MongoDB, you have to open a MongoDB shell. So you have to tell which area you want to open. So there's a test BA database. So we are going to use this database. So right click on it and I click open shell. So the shell is opened here. So once the shell is opened, I can use this icon on the top left corner here, this one. Basically, it looks like a folder. So this is a menu to load a script file, JavaScript file into the MongoDB. So if I click this, I can go to the desktop and there is zips nyil.js. So I click open, then it will be opened here. And then I can click the play icon on the top, this one, to perform this JavaScript code. So if I perform this, basically what's happening is that this JavaScript code will make a CD collection inside your database, and it will insert all this document into the CD collection. So do this and close this and do the same thing. Right click on the test BA database, click open shell, and open the second file, zips txca.js, open it, and click play icon again, and then it's done, and close. And once you right click on the test BA database, and if you click refresh, you will see that the CD collection appears here. Now, if you right click on the CD collection, and if you click view documents, you will see that a lot of documents are added into this CD collection. And it looks like this. You can open something to check it. So basically, that's how you can populate CD collection using these two JavaScript file onto your MongoDB server. So once you do this, then now you can check probably structure of the document stored in the collection. So basically, each document contains this information. There's an ID field. ID field contains 5-digit number. Basically, it refers to a zip code, the zip code in the US. And the second field is a city. So it contains name of the city. So where this zip code belongs to, it belongs to New York City. And the location information is a combination of two elements. Basically, this location data is for GPS location, longitude and the latitude information. And there's a POP field. POP field contains population information. So in this zip code 101, there are 18,913 people living there. And the last one is a state field. It says that the zip code 101 belongs to state NY. So it belongs to New York City in state NY like this. So for the state, there could be 4 different things: NY, IL, TX, CA, basically New York, Illinois, Texas, California, like this. So basically, this data set contains the zip code information in the US across 4 major states. So that's and the population information together. So that's the main data we have in this city collection. So given this data set, now we can practice some query. So query in MongoDB is basically a process to find documents that satisfy certain criteria. So it's similar to relational database, right? In the relational database, we have SQL query. If we use SQL query, we can find a certain data from table. In this case, we are finding documents from collection. And query is used in many different functions and operations in MongoDB. So for example, in the read operation, we have this find function. So we specify database dot collection name, which collection we want to find the documents from. And we specify find the function, and we specify query here to do read operation. Also for update operation, we use query. We specify cd in update function. And here we use query, update rule, option rule like this. For delete, remove function, we also use query here so that all the documents that match with this query will be deleted from the collection like this. So let's try to run how to design and how to utilize a query using step-by-step hands-on exercise that I prepared on this slide. So first of all, when you design a query, we follow this structure. So basically, it's like this. We have an open here query. It looks like open document, and this represents the end of a query. So end of a document, right? So here we specify key and value to specify our query. So that's the basic structure. And if you want to find all the documents from the collection, so something like this, right? So in this case, we select everything from CD. So if you want to find the entire document from the CD collection, then you can do this. You can specify DB database, that name of collection you want to perform your query, and find the function, and simply open bracket and close bracket. Basically inside here, you don't put anything. Then this will retrieve the entire document from collection. So let me check this, how this works. So here, let me close this. Let me close this tab and right click on test BA database. Let me open a new shell to practice here. So here, if I type db.cd collection dot find the function, and if I use open bracket, close bracket like this and perform this code, then all the entire documents stored in CD collection will be retrieved like this. So that's how you can utilize this query like this. And if you want to specify a certain condition, so in the relational database, we use the where phrase, right? We use the where phrase to specify a certain condition like this. In the MongoDB, you can use key and value. So you specify a certain field or certain key, and it should match with this value, then you can specify like this. So in this case, if we want to find all the zip code documents in the state NY, then you can design state should be N, Y, like this. You can design this query, and then this will give you the result that you want. So if I try this here, now I can add state NY like this. And if I perform this query, then here's the result. So if you, it looks the same, but if you actually look at each document, all the documents here in the results will have a state NY like this. So you can confirm that. So next one, multiple condition. So in the MongoDB query, you can also specify multiple condition with a comma. So if you list many conditions like this with a comma, then all these conditions should be satisfied to show the final result. So for example, in this case, you want to find all the zip code documents only when they are in the state NY and also located in the city named medicine. So there are two conditions. When these two conditions are satisfied, you want to show and find those documents. Then you can use this rule. So basically, open bracket, and here the first condition is this: state should be NY and comma, and then you can specify the next condition, which is a city should be medicine, like this. So we can try this. We have two conditions with the comma, and then here in the MongoDB, so we already have state NY, so I can add here one more condition, city medicine, like this. So if I perform this query here, then there's only one zip code, 13402, that belongs to here. So that belongs to city named medicine in state NY. So zip code 13402 satisfy these conditions basically. So you can confirm that. And the next one is specifying returning keys. So currently, in the earlier example, when you just specify query, and if you perform the query, then the MongoDB will return the entire document. So document may have many different fields, and some fields you may not really need the information, right? In that case, you can utilize returning keys. You can specify returning keys to select only a certain field to be returned as a query result. So the format is like this. When you use find function, you can specify query here, and after query, specify comma, and then you specify returning rules. So returning rules can be like this. So open returning rule, close opening rule, and inside you specify what you want to show, what you want to hide. If you want to show a certain field, you can specify that field, and you can put 1 to show it. If you put 0, it is not showing in the result. And for the ID field will be automatically showing by default. So if you want to hide the ID field, you can specify ID, comma, ID colon 0 like this. So in this example, if we want to find the population information only of the city medicine in the state NY, then we can design this query in MongoDB. So here, first of all, we design query first. The query is this: we have to find the documents which is in city medicine in the state NY. So the query will be state NY and city medicine. So this is query. So here, start of query, here, end of query. So the query is done. So after the query, put a comma, and then you specify the returning rules. The returning rule is that I want to see population information. So population 1. However, for ID field, I want to hide. So ID field 0, like this. For like regular fields, if you don't put 1, it will not be shown in the result. But only for ID field, if you don't put 0, it will be shown by default. So we set like this, and let's test this and see how it works. So already I have this query. So inside the find function, I have this query. So at the end of query, put a comma, and then returning rule is a population field I want to display. However, ID field I want to hide by putting 0 like this. So that's it. So if I perform this function here, then here's the result. If I open it, there's no other field. ID field is not shown. Only population field is returned as a result. So population 1,472 in city medicine in the state NY, like this. So that's how you can specify returning rules in MongoDB. Also, similar to the MySQL, we can utilize comparison operators. So you can specify some comparison rules. So if you don't want to find an exact match of the key value, so there's a key field, and the value stored in this key field should be greater than or less than a certain value. So you want to compare. Then you can use comparison operator. The rule is this: specify key, and here start with this open bracket, close bracket, and inside here you specify comparison rule. So how you want to comparison using operator and specify the value you want to compare against. And the comparison operator you can utilize are these things: equal, not equal, greater than, less than, greater than or equal, less than or equal, like this. So if we want to find all the zip code with the population more than 100,000, so here what we want to compare is a population field. So we specify that for this query, we specify population first. So we want to compare population, and the comparison operator is more than. So more than is this one, right? Greater than. So we put comparison rules with the comparison operator greater than, and we compare against this number. It should be greater than 100,000. So 100,000, and close like this. So if you perform this, let's try here. So in this case, we are comparing population, comparison operator greater than against 100,000, like this. So if I perform this code, there are 4 zip codes basically. So in these 4 zip codes, you can see that the population is all greater than 100,000, like this. So 3 zip codes are in the New York state. 1 zip code is in the Chicago, Illinois state, like this. Okay, so let's go to the next one. So another comparison operator you can utilize is this in operator. So this is similar to the basically in operator in the MySQL. So in operator, you can use this when you want to find the key values matching one of multiple options. So this key value should be matched with one of these options I list here, and then I want to see the result. Then you can use the in operator. So in operator and list the options you want to show. So in SQL, it can be similar to the utilizing where phrase with the equal sign and or operator like this. So in this case, if we want to find all the zip code with the population of this or this, then we can design the query like this. So first of all, what we are comparing is a population. So we specify that first. The population will be compared. In this case, it should be either this or this. So we use the in operator. And then we list the option here as element. So first element, second element in a list like this, and close bracket, close bracket. So this one you can also try here. So in this case, I use in operator, and the list of option is just 3,593 and 26,365 like this. And if I perform this code, here is the result. So basically zip code 104 has population of 3,593. Zip code 1012 has a population of 26,365. So basically based on this query, we can retrieve 2 documents from the collection. Another operator is a not in operator. So this one, So this one, if you can use when you want to find the key values matching none of the given option. Then you can specify multiple value in a list as an element. And when you want to retrieve information when this key value doesn't match any of these, then you can use not in operator. So this will be the same as you use utilizing where and not equal and end operator in MySQL. Oops. So here, if we want to find all the zip codes in neither NY nor CA, so we want to retrieve zip code information when they are not in NY and not in CA, then we can use not in operator. So first of all, it's the same. What we want to compare is the state. So NY, CA, this is state information. So state should not in NY or CA like this. So that will be the code to solve this example, this exercise. So here we can change this code. So instead of this, we can have a not in operator. Oh, let me have to start again because we have to compare state not in NY or CA like this. So if I perform this query, here is the result. If you look at the document, you can see that none of these documents are in NY or CA. This one is Illinois, Illinois, Illinois like this. So you can check it. So you can also utilize logical operators in the MongoDB, just like we did in the MySQL. So in MySQL, we had the AND operator, OR operator, NOT operator. Exactly the same thing exists in the MongoDB. So AND operator, if you want to utilize multiple query, you can use it. So when you're defining the query like this, you can open an AND query. Here you can use the AND operator first, and then inside the list, you can specify multiple query as elements. That is possible. Then all these conditions should be satisfied to show and return the result. So in this case, we can do the same thing, find all the zip codes only when they are in the state NY and also located in the city named Madison. Then we can solve this query also utilizing AND operator. So we can start by using AND operator. And then the first condition is state should be NY and CD should be Madison. And end of the list, end of the AND operator. So basically here is the one query, right? State should be NY. Here is the second query. CD should be Madison. And we use AND operator and it's a list. So basically these two conditions should be satisfied to send the results back to the user. So in this case, we can do this too. So we utilize AND operator. And here, first condition is the state should be NY. Second condition is that CD should be Madison. Like this. So if I perform this query, here's the result. Basically, there's only one zip code which belongs to city, medicine, and state, NY, like this. Okay, there's also OR operator. If you want to find the key values matching one of multiple conditions like this, then you can specify multiple condition in a list, and then you can use the OR operator. So in this case, you want to find all the zip codes which are in Medicine NY or Berkeley CA. You can utilize OR operator to solve this question. So for this one, we can specify OR and list of condition here. The first condition is city, medicine, state, NY, or second condition, city can be Berkeley, state should be CA, like this. So we can type this here. So I change this part. So basically, start with the OR operator and list two conditions here. The first condition I will list is that city should be medicine, state should be NY, and then comma, and then second condition is city should be Berkeley, state should be CA, like this. And then if I perform this query, here, there will be multiple results. So there's one document that belongs to city medicine in New York State. There are other documents, they all belongs to city, Berkeley, state, CA, like this. And the next one is the last logical operator, which is not. So if you want to find the key values not matching a certain operator expression, you can use not operator. So you can use not operator after the key field, and you can specify operator expression. So here's one example. We want to find all the zip code with the population less than 100,000, or not less than 100,000. So we compare population not less than, like this. So if we want to design this query, basically we start with the population because we are comparing population. So we start with the key first. So population, and we use not operator because not certain condition. So we use not. Condition is less than 100,000. Like this. So here, one thing you have noticed is this. So the not operator works in this way. So let's say that you have a collection. So in the collection, there are multiple documents, right? So each of these is a document like this. So inside this collection, inside this CD collection, there are many zip code documents. And this query will check whether there's a document with a population less than 100,000 first. So let's say that these documents have a population with less than 100,000. Then based on this query, it will select this document first. And there's not operator. So this selection will be inversed in this collection. So except for this selection, the rest of documents will be returned. Then they will have a population greater than and equal to 100,000, right? That's what we can infer here. So if we perform this query, basically, it will be straightforward. So the result we will observe will be this. So population not less than 100,000. If we perform, we can see that there are 4 zip codes. If you look at the population, it's not less than 100,000, right? It's bigger than 100,000. Same here, same here, same here, same here. So these 4 zip codes has a population not less than, basically bigger than 100,000. So that's what we want from this query. So it is there, but this one is actually a little bit tricky. So if it's not less than, then we can just use greater than or equal to, right? So these two should give the same result theoretically. So this is greater than or equal to 100,000 is conceptually same as not less than 100,000, right? So it should give the same result. So let's try. Will they give the same result? So I have this query here, and above this, I make the query which is shown on the slide with instead of not less than, greater than, equal to 100,000 like this. So if I perform these two queries, here are the results of 2 queries. So as you see, the results are exactly the same. They both return 4 documents which with the same exact zip code. They all have more than 100,000 population. But what if you insert the last one here? What if you insert this document? Then will the results different? One thing you have to notice is that in this document, there is no population field. The field itself doesn't exist. So let's try what happens first. And let's discuss after that. So we insert db cd. In the cd collection, we insert new document with the ID 99999 cd, just a random name, test, and state NA like this. So basically, we just made up this zip code for the test purpose. And this document doesn't have a population field. So we add this, and if we perform these 2 codes, let's just see what happens. So now I click this play icon. Then because of the first part, it adds 1 record into the CD collection. And for the second part, it gives you this result. It's the same, right? The population field doesn't exist in this new file. So when we compare greater than or equal to, there's nothing to compare. So the new, this new one is not included in the first query. So when we run the first query, there's no population field here. So we don't consider this as part of a result. So it's the same. How about the next one? But we also have this last query, right? Which utilizes not less than. For this one, actually, the new document we just added is included here, even though it doesn't have any population field. So what's happening is because of a not operator. So earlier I mentioned that if you use a not operator, it will inverse the result in a collection. So what's happening is this. So in your collection, you have many different documents. So this is your CD collection. You have document, and many documents. And the last one is the new document we just added. So this is a new document. So first of all, it compare this part, population less than 100,000. So let's say that this part has a less than 100,000. So we select this part first. And this part will not be selected because it doesn't have a population field, nothing to compare. So because of a population and less than 100,000, this part will be selected. And we have a not operator. So we exclude this in a result and we return the leftover from the collection. The leftovers are this. Even though this one doesn't have a population field, because we inverse the result, this entire result will be returned. That's why here we see this last document added when we use not operator because it doesn't have a population field. So that's something you have to be careful when you utilize a not operator in the MongoDB. So that's there. And the next one is this. So if you want to make a comparison only when a certain field exists, you can use this exists operator. This exists operator will check whether a certain key field actually exists or not inside the document. So if it exists true, it will check whether the field exists. If it's false, it will check whether that field doesn't exist. So for this second query, if you want to make a change to give the same result as the first query, then you can use exists operator here. So basically what you can do is this, everything same. You can use pop, so population should not be less than 100,000. So here it's all same. And here, so this is the first thing, the population should not be less than 100,000. And then we add one more rule here. One more rule is that also the population field should exist. True, like this. And then these two conditions should be satisfied to be included in the result. So it should not be less than 100,000, and also population field should exist. So the last document with the 99999 ID will not be included in the result with this query because it doesn't have a population field. So if we perform this query, now it will work fine. So let me delete this one. And now here, basically here, after population also needed to exist. And then if I perform this query, now you can see that the results of these two queries are exactly the same. So that's the role of exists operator to check whether a certain field exists or not in the document. So here's one exercise. So this is based on this. So basically the question is this: find all the zip code documents with a population between 80,000 and 82,000. So we can design this query based on without end operator and with end operator too. So it's similar to the relational database too. So in the SQL, when we talked about it, I mentioned that there could be multiple solutions, multiple design of SQL that will give you the same result. In the MongoDB, it's similar, so it's coding. So basically, depending on how you code, it may look different from the outside, but it's possible to give you the same result. So in this case, we can design one query with the end operator, the other query with the out end operator. So for the time concern, so I just show you how we can design the query for this question. So the first query can be something like this. We can have DB, so database, and the information documents is stored in the CD collection, so db.cd, and we use the find function, so specify find, and then operator we want to specify is this. So we have to compare population field. The population field should be, the value should be greater than equal to 80,000. At the same time, it should be less than equal to 82,000. And close like this. So basically, we list this condition on the population field like this. So that's the one solution. And another solution with the end operator, we can also design something like this. So db.cd.find. So this part is the same. However, in this case, we use end operator. So use end operator, and we list multiple conditions. So the first condition will be population should be greater than equal to 80,000. Like this. And the second condition will be population should be less than equal to 82,000. like this. Okay, and then finish like this. So there could be two potential designs to solve this question, and they will work at the same way. So I skip doing this in the MongoDB, but you can try these two query and see how it works. They will give you the same result and same answers basically.